Hello guys, I'm here with Alex Eres. This is a good friend of mine, and today we are going to explain some really interesting topic: how to clean a formula in the first order logic. This is going to be really interesting for you. And at the beginning, let me start with some important information about what is the free variable and bound variable, which is the aim of this exercise. We're going to check this free variable, and we're going to represent one row and also one bound variable with one A and another A, and this line which means the bounded in this exercise. Okay, so let's start over. The first step is free a variable intersection bound is in 0. And the second step is going to be differentiate the quantifiers bounds and the differentiate variables. Isn't it, Ali?
Yeah, that's right.
Okay, so let's start. Where is it? Okay, we have one group. Okay, so this is the exercise, this is the formula, and Ali going to describe this formula. Can you read it, please?
Yeah, it's negation, and this is negation. Existence x, px implies universal y, q, x and y equivalence with negation of py.
Excellent. So do you remember this information? Free variables and bound variables.
Yeah.
So the first step is trying to find the bound variables. So we're going to use this formula to bound it. So here we can bound this part with this. We have one in a universal y, and we have one y here, so this is going to be bounded as well. And we have free variables. The x is going to be free, and the y is going to be free.
Yeah, Oswaldo, and one more thing, like when you are bounding something, some variables with, if the variables, this one, if they are, so this variable is with the quantifier, and also this variable with the quantifier. We have to bound those variables which are with the quantifiers and which are the local variables. These are the local variables, these are the local variables, and these are the local variables. So we can bound the variable which is with the quantifier with the local variable. As my friend, you just did that, like this x is bounded with this and this y is bounded with this. What is the reason to bound those variables? Okay, the reason is to bound them, like we don't in our formula, to clean our formula, the first step is that there shouldn't be any common. As you can see easily, this x is common because there are two x exist in the same formula. 2y exists in the same formula. I know that this is also y, but this is, we can explain how we can do it. As just Oswaldo did that, like this x, because this x is bounded with this local x. The reason to bound this, because this is the quantifier with the variable. This is the whole formula. This is one formula, this is another formula, and this is a different third formula in the whole formula. This is the whole formula. This is sub formulas over between those combinations. These are the conjunctions, basically, like implication and equivalence. Now we bound this x with the local x, and this y with this y, and this x is the free one and this y is the free one. Why we did it? Because we need to clean the formula, and within this formula there shouldn't be any common. Now go to you, please. Now as we just did the bounded step, and within the first step the next thing would be the variables which are being bounded will be renamed, and it will be renamed any other variable except these which are in this formula, like x, not y, not p, except these any variable, as like my friend is doing, like this is u, we renamed x with u and rename y with w, but not the free variables like the x, because x is the free variable. We only rename the variables which are bounded, like x in the beginning of the formula, this and also this.
Okay, so
Yeah, and
here we
this
are.
y, this is the free variable. We don't need to mention it because we just mention it for you. Now the first step is done. The second step, please could you show them the second step? Okay, right now we are done with the first step, which is free variables. There is no common between free variables and the bound variables. Now the second step, which is we have to make a difference between the quantifier bounds and the different variables. What does that mean? Let me show you with the question. In this question, you can easily see that this existence u is the quantifier. This is not the quantifier, because this is the variable, different variables. These are the different variables and these are the different variables. So we have to differentiate this quantifier from out of this all these variables. This one is out of it, but this with this. How you, for solving this, there are some certain rules. We have to follow the rules, and without those rules you cannot solve this question. So here comes the rules.
Here comes. This is the kind of rules that Alice is talking about. So we have many. In fact, you must know these rules. Without of these rules, it's almost impossible to solve or continue with the exercise, isn't it?
Yeah, that's right. That's right. Now, we're gonna take these rules here in front of this, because this will help the students to get it, what we are talking about. So, right now, just focus on the first rule of it, which is there.
Okay, that doesn't matter what is the rule. It must match this rule. So it's this one. Is a negation in universal x and
Yeah, no, wait, not this one. Look at this. This is negation of existence.
oh yeah.
X and A. We call A to the whole of it. Not go further. Just this PU. This is A, and negation E. U is comparable as X. So,
Yes, and here is matching.
Yeah.
The existential and the existential is matching. It's
Yeah.
look like.
Yeah.
So this is going to be this, and the A is going to be P and U.
That's right. So this negation existence X A is equal to universal X negation A. Just
Okay.
Oswaldo, could you write it down, please?
Yes. So we are going to put now a universal U, negation, which is here
Is A,
negation A, but
which is
now
PU.
it's U.
Yeah. Alright. Every time when you're going to solve the question, just you have to compare the formula with these rules. Right? When you compare them, you will easily see what would be your next step. As we just did that, we just compare this with this. So we knew what we need to do, and the rest would be the same, implication and this rest.
Okay, so it's going to be with parentheses universal U.
No, Oswaldo, it's not U, it's W.
Is W, yeah.
Yeah.
Is W, and then Q, X, comma, W, and then the equivalence negation P, Y.
Yeah.
And I close these parentheses.
That's right, that's right. Now, as we use the formula, these rules into this formula, let's have a look. What would be the next rule we're going to apply on it?
Okay, so I think, can we work with this part or just this part? We solved this part.
As we just did this part, and you missed something, here is the implication sign.
Oh yeah,
Yeah?
it's missing here. So
Yeah.
I put here the implication.
Yeah, and as you solve this part, you can put the overall parentheses from this to this,
Okay.
to the whole formula.
Here, Ali?
Yes, that's
Okay,
right.
this is one parenthesis. This is really important, this parenthesis, in
Yeah,
fact.
this is very important. This will tell you what you solved and what is remaining. Okay, now this part we need to solve it. Let's have a clean look right now. Yeah, so you know what is the second step is, let me remind you, we need to take those quantifiers out of the parentheses. As you can see, this quantifier is in the parentheses, and the second one is this, is also in the parentheses. What we need to do, we need to pull them out of the parentheses by using these formulas. Okay?
Okay, so it seems like this is almost the same. Is here parentheses and one universal X, A or B.
Yeah, how are you gonna put them? Could you tell them how you gonna use this formula on it?
Okay, so I'm going to take out the universal X and then I'll just copy the rest. So I'm going to do this. I'm going to put universal U, and then the A. The A is negation. Okay, I think we have something new here, because here is one implication. So I'm going to take this universal, as you can see in the formula, there is one universal, A implies B, and here this is could be universal, and this is could be the A implies, and everything the rest is B. So how can we solve? If this is the universal X, well, we're going to put the existence X, A implies B. So maybe this is a little bit mistake, but don't worry, it's not so much, it's better to correct. I'm going to put in another color. So let's say the existence U, and then the representing A, no, and the parenthesis is really important, the parenthesis, and then the A, which is negation P U, and then implies implication, and then the B, which is, this is the B, all the rest. So I got to put parentheses, all W, Q, X, W, equivalence, negation, P, Y, this parenthesis. Okay, so I put another parenthesis.
Yeah, you know, as my friend just did, this quantifier out of the parentheses. Now there is one more quantifier in the formula, which is this one. We have to figure out to pull this quantifier out of this.
Okay, so there is one thing, that this is one equivalence sign. So if we check the rules, here we have something in parentheses A equivalents B, and this is the solution for that. So let's solve it, just this parenthesis. I'm going to solve in this way. This is going to be the A, and this is going to be represented the B. So I could say solving that A, which is going to be universal W, Q, X, W, and well, this is my first case, then implies, then I'm going to put implication B, and the B is going to be the negation P Y. This is the first part, and I close with the parenthesis. Then I'm going to use the conjunction B in parentheses, and the B is going to be the negation P Y, and then is going to be the implication A, and the A is this everything, universal W, Q, X, W, and I close this parenthesis. Okay, so it's really important to remember the missing part. So it's one parenthesis here. I'm going to also put this implication, well, the rest that we missed before. I can put P, U, this is one negation. I need to close it, this, and the quantifier existence U.
Yeah, and one more thing, why did you solve it? You solved it because you wanted to take this quantifier out of the parentheses, and you're just doing it because there is no such formula in this line which is equal to equivalence, only this one, and you just implement it here. Just follow, just go forward. Okay, now you have to solve this implication and then implication, because these are the two, as you can see, two quantifiers here right now. You have to take these two quantifiers out of the parentheses. Use those formulas for this A implication quantifier B. There would be some formula here which would be A implication, this one would be the formula. We're gonna use this formula here in this part.
So that means I'm going to use this formula.
Yeah.
A is going to be this is going to be the A.
Yeah.
For me, this is going to be the A, and this is going to be the quantifier.
Quantifier.
The quantifier, and the part
is B.
This is B.
Yeah.
This is going to be the B.
That's right.
Okay, pause.
All right. Right now, as we can see that this A implication quantifier B, what we're gonna do to solve it is,
well, there is some one little mistake that we can correct right now.
Ah, okay, I just saw this, yeah. Basically, we are solving this parenthesis because we don't need to solve this PU here because there is no quantifier there. This is out of the this variable is a different variable,
yes,
which does not contain any quantifier, but this one is. So we have to solve this, which is in quantify A implies B. So this would be the B, and this would be the A.
The A, okay.
And this will be the quantifier, right?
Yes.
So just have a look of this formula and see which one needs to be applied. Okay, this one, because this is the quantifier A implication B, which is equal to this quantifier out of the parenthesis, existence quantifier out of the parenthesis, and inside the parenthesis A implies B. Let's do it. Alright, write the rest, which would be EU and this parenthesis negation of PU, implication sign, implication, and then this parenthesis, solve this parenthesis because we have to pull this quantifier out of the parenthesis. Alright, what you're gonna do, this existence, this quantifier will out of this parenthesis, will be here, out of this parenthesis, which is W, and what we have here is just Q, X, W, implication, negation, P, Y, and this parenthesis, this one, and this one. We just pull this quantifier out of the parenthesis. This quantifier pull out of this parenthesis, and by using this formula, A implies B. As you can see, this existence X out of those parentheses. Okay, now this quantifier will be changed to the other one. This is the universal. This will be the existence. Here, sorry, that's my mistake. This will be universal. Oh, sorry, existence W instead of universal W. According to the formula, if you just look at the formula, universal X implies B.
Change to the
existence X within the parentheses A implies B. We did that. Now, by doing the rest is and P negation P U and the implication sign of universal W, which is a quantifier Q X W, and this parenthesis for this, and the main parenthesis this one to be this one. This one would be this one.
The complete parenthesis. Yeah.
Now, only one quantifier exists, which is this one. Only this quantifier exists. We need to take this out of this parenthesis. What we're going to do, if we look in the parenthesis, what we can see, this is A, implication, quantifier B, universal quantifier B. Let's have a look. Which formula needs to be put in it? I think this one, because A, implication, universal X, B, and this is the same. A, implication, universal W, B. So, let's continue. What we need to do now, just this part will be there. Okay, let's do the rest, which is EW, EU, and let's have a space for those quantifier here. Write the rest, PU, implication, sign, open parenthesis, Q, X, W, implication of negation PU, the conjunction, the AND operator here, and then open parenthesis of A. As we follow this formula up here, what is going on? This quantifier goes out of the parenthesis, this, and just A and B in the parenthesis. We will do the same here. This A, implication sign, only the B will be here.
Only just
the B, X, W, and the parenthesis, and this AW will be on this side out of the parenthesis. Yeah, Universal W will be out of this parenthesis and appears here. Now it's done. What we are looking for, like these are the quantifier and this is the different variables. If you look, just have a look again to the what was the purpose of the second part of it?
Yeah, it's here.
Okay, it's here. Start again. Second step, different quantifier bounds and different variables. These are the different quantifiers: existence W, existence U, existence universal W. These are the quantifiers. These are different. These are pulled out from the parenthesis, and the rest is all the different variables. You can see we are done with those first step and second step now, and this formula here is clean. This formula.
The formula is clean.
This formula is clean, and that was the only purpose we had. We are done with that.
Okay, so I need to thanks to my friend Alice, and thank you for watching this video. I'm sorry this is long, but this is really important to solve it step by step, because the beginning is the most important part. Thank you, and let's see you in the next.